Okay, here we go. The last recording of the year. How about that? Let's change. Of course, I always forget to do this before I start recording. Let's go to red. And let's change that to 0.75. All right, we should be good. So I'm going to do chapter 6 first, okay, because we just finished doing it, and the grades weren't as good as I wanted them to be. So let's go through it. So hopefully this helps get the problems right on the exam. The problems will be just like this, but the numbers are going to be different. So don't just sit and memorize the answers to the test. I was going to say something else, but I'm not going to now. Here we go. It says, find the sum of the measures of a convex hexagon. First of all, how many sides is a hexagon? Somebody talk to me so I know you're awake. 6 sides. All right, 6 sides to a hexagon. If I want to find all the measures of all the angles inside a hexagon, it doesn't have to be a regular hexagon. I just need any 6-sided figure. If I add up all the angles inside, this is how you do it. You remember the formula? N what? Minus, anybody? 2 times 180. That's right. And I may not, and I probably won't, and I cannot find, did somebody take, I had a whole bunch of answer sheets up here. Nobody picked them up. It'd be really nice if you gave them to me. Oh, I know what it is. That kid left my class, and he knocked stuff off my desk into the trash can, and there they are. Look at that. He didn't pick everything up out of there. All right, let me find the answer key just to... And I put all the answers on your test anyway, right? Unless you got 100 on it, where you already had all the right answers. All right, so anyway, what are you going to put in for the n? Hexagon is what? 6. So 6 minus 2 is 4. 4 times 180 is 720. That's how you get it, okay? I'm telling you right now, it's not going to be a hexagon. Silas, even though you don't have to take this, put the phone away. You still can't have a phone out. All right, so what if I want to find each interior angle of a regular, this time it's an octagon. So what I'm going to do is find out what the angles all add up to be first, just like I did on number 1. And then you're going to divide it by how many angles you have. So let's find out what all the angles add up to be. So it's n minus 2, or this time it's 8 minus 2 times 180. And then I want to find each, look, I even put it in all caps. I want to find each interior angle. And it's a regular octagon, so all the angles are exactly the same. So I can find what all the angles add up to be, which is this number, and then I divide it by how many angles that I have. How many angles do I have on an octagon? I got 8. So you put that into a calculator. 8 minus 2 is 6. 6 times 180 is whatever that is. Divide it by 8, and that comes out to 135. That means each angle in an octagon is 135 degrees. All right, let's do this. This is a pretty easy one. I think a lot of you got this right. Even if you missed a whole bunch of problems, this is probably one that you got right, I hope. If not, I'm going to show you how to set it up. I'm not going to do every little step, okay? I'm not going to sit here and do all the algebra for you. I'm going to just set this up because I got 2 tests to go through, and I only got 25 minutes, and I really doubt I'll be able to get much done on chapter 5, but it's still going to be on the final, so make sure you understand that. So it's a rhombus. What's true about all 4 sides of a rhombus? They're all equal to each other. So what must be true about this side and this side? They are equal to each other. So I set them equal. And then you do your math, you solve for x, and it says find the length of each side. Just solving for x. Is that my answer though? No, I got to plug it in. I got to plug it into either one of these, and it does not matter. So when you solve for x, I'll give you a little help. X is equal to 5. And then when you plug it in to either one of these, it doesn't matter which one you plug it in, you're going to get, it says find each length. So, well, it doesn't matter which one you find. The length is going to be, this is number 3, right? This says find the length of each, and then on my answer thing, I put EF equals, but it doesn't matter. So each length of the side is going to be 6, all right? So this will be 6, so is that, so is that, so is that. It says find the length of each side. Is that what your test says? Does your test say because I've done some changes on some of these tests. I don't know. This may not even be your test. Did you have this problem on your test? Yeah. It was? Okay. All right. Because again, I've made some changes and I didn't know which one I actually saved to put up on here, but okay, that's good. All right, here we go. Angle P. This angle right here. Super easy. No math involved. Look, you guys got to get this because this helps you out on a couple, at least a couple different problems. All right. Do you remember when you have two parallel lines cut by a transversal? Remember that? What's true about this angle and this angle right here if these lines are parallel? They're equal to each other. We have a name for them. I don't even ask you the name for them, but what is the name, just so you remember? Alternate interior angles. Very good. Okay, these are alternate interior angles, and they are equal to each other. Look at this. Look at angle P and look at 120. This is parallel to this. We know that because it's perpendicular. They're both perpendicular. All right, so that means that these two are parallel, which means that this angle, let's do it like this. This angle and this angle, look at them. Aren't they the same angles? We've got two parallel lines, got a transversal. So this angle and this angle are exactly the same. So you don't have to do any work for that at all. All you got to do is look at it and write it down. Okay, there's no work to show. Now, on a lot of these, there is work to show. Okay, I would say on most of them, there's work to show. All right, here we go. What about this one? These are pretty easy. This is a, what's that little symbol right there? What does that mean? Anybody know? What is it? Rhombus, that little symbol? It's a parallelogram. Okay, now rhombus is a parallelogram, but that means parallelogram. So this thing right here is a parallelogram. So what do I know about parallelograms? Well, I know the opposite sides are equal, right? So I know that this and this are equal. I know that this one and this are equal. What do I know about the diagonals of it? What do they do to each other? They bisect each other. So if this little bit is 3.8, what's this little bit right here, k to n? That's going to be 3.8, yeah? Look, JL, it goes from here to here. That whole thing is 6. So what is it from J to N? It's half of it. That's 3. N from N to L or L to N, that's 3. So without even looking at the problem, I know a lot of stuff. So let's see what they asked for. They asked for NL. Where's NL? From there to there. We already found it, didn't we? It's 3. So NL is 3. What's KM? There's K, there's M. Look, KM is this little part, what? Plus this little part right here. All right? You just add them up. Can you do that in your head? 7.6, that's right. So that's 7.6. That's how you do it. I had a lot of people putting 6 for that one right there. 6 would be JL, and they already told you JL, didn't they? All right, so make sure that you know what you're trying to solve for. Put that stuff in. As soon as I see that's a parallelogram and I see the diagonals, I'm thinking, hey, look, I know that whole thing is 7.6 because I add those two together. That whole thing they told you is 6, so I know each of those is half of it, so half of 6 is 3. Everybody with me? Did I start recording this? I did, okay. I would hate to do this whole thing and not record it. All right, let's do this one. We had a little struggles with this, but this is actually super easy. We didn't go over this a ton. I don't even know if I had this on the quiz. I'm not really sure, but we did teach it. All right, so if you got a bunch of parallel lines, and you got these transversals, check this out. See how this little bit right here is equal to this, is equal to this? That means anytime I put a transversal anywhere through here, those little segments are all going to be equal to each other, okay? Because they told us that this one, and this one were equal. So what does that mean about little AB right here? And BC and CD? They're equal to each other. It doesn't mean they're equal to these right here, but they are equal to each other. What about from here? WX, XY, YZ. What's true about those three little segments? They're all equal to each other. So let's see what they tell us. They say find AD if BC is 2. So where's BC? BC is that little bit. That's 2. What are they asking for, though? AD. They're asking for the length from A all the way to D. That's what they're asking for. Well, if that's 2, what's this little bit AB? That's 2. What's CD? That's 2. What is it from A all the way down to D? It's 6. 2 plus 2 plus 2, which is 6. Really basic and simple, isn't it? Everybody should be able to look at that and say, okay, yeah, that makes sense. I get it. If they're all equal to each other, I just got to find the length from A to D, fill them all in, boom, you're done. What about this one? It says XZ is 6. XZ. So that means, look, from here to here is 6. And you want to find WZ. WZ, again, you're finding the whole thing from the top all the way to the bottom. Oh, well, how do I do that? Because I don't know the little segments in between. Well, I should know, because what's true about this little part and this little part? They're equal. And if they add up to 6, what are they? 3. So that's 3, that's 3, and that's 3. So what is it from W all the way down to Z? I'm sorry, yeah, WZ. 3, 3, 3, which is what? 9, so that's 9. So that would be 6, and that would be 9. Super easy. Would you agree? You got to agree on that, yeah? One of the easier things, I think, that we do in here. All right. But if you didn't know that rule, if you didn't know, but now you do, and you should have known before. But anyway, let's keep going. Angle 1. So we're trying to find angle 1. So this is a rectangle. What do we know? What do we know about, well, we know this is parallel, don't we, to this. So again, this is one of those problems you don't have to know any math at all. You got to know geometry, but you don't have to do any algebra. Why not? What's the relationship here? Angle 1 and what else? Anybody here? Nobody's talking? Come on, we did this already. We had parallel lines cut by transversal. Here's my two parallel lines. This AC is my transversal. What's true about angle 1 and 35? They're equal to each other. That's right. Okay, they're equal. That's all you do. Okay, just say angle 1 is 35 degrees. Angle 2 is a little tougher, but watch. I can use either this top triangle right here or this bottom triangle right here. It doesn't matter. Let's use the bottom one. Do you see how these two sides are equal to each other? If this is 35 degrees, tell me something about this angle right here. This is also 35 degrees. Now, what am I trying to find, though? I'm trying to find angle 2, which is the same as this one. So I got 3 angles in a triangle. What do 3 angles of a triangle add up to be? Anybody? Neil's doing all the answering, and he's not even taking the test. Somebody help me out. 180, right. They add up to 180. So 35 and 35 is 70, and then 180 minus 70, and you should do the math on here. Okay, so 180 minus 70 is what? 110. And that's how you do it. That's this angle, and angle 2 is going to be the same thing because they're vertical angles. They're equal to each other. Everybody good? This test doesn't seem that hard now, does it? Maybe that's why we got a couple people got 100. Maybe that's why. All right, let's do this. This one's a rhombus. And look, they already tell you. They didn't have to do this. Me. I'm the one that made the problem up, okay? I put it on this test. But I didn't have to put the 2 or the 4 tick marks on here because just saying that it's a rhombus, that already tells you that all 4 sides are equal, okay? But I put them on there just to make it a little easier for you. EFG, where's that? EFG, that's this one right there. How in the world am I going to find that? Well, look at this. Let's find this one down here. We have to know something, though. On a rhombus, the diagonals, they do a couple things. Well, 3 things. They bisect each other because it's a parallelogram. They're also, what? Perpendicular. Okay? And they also do something to that angle right there. What do they do to that angle on a rhombus? What's a wild guess? What do you think they do to that angle? They bisect. They split that angle into half. All right? So if that's 60, that's 60. What's this whole big angle G right here? It's 120. So how do I find big angle F right there? These are supplementary. So I go 180. Let's do the math. 180 minus 120, and that's 60. So that whole big angle is 60 degrees right there. That's how you do that. And there's your work. 60 degrees. Everybody with me? All right, so watch. If this whole big angle is 60, what's this big angle H right here? That's also 60. But it's being bisected, so what's angle 4? It's 30. It's half of 60. All right? You just got to know a few things. All right? And it's a matter of studying, going over your notes, watching the video, that kind of stuff. Have I said that enough? How many times this year have I said, watch the video? Probably about a few hundred, right? At least. So that's what that would be. That would be 30 degrees. Not too bad if you know what you're supposed to do. If you know the geometry, what angles are equal to each other, if it bisects it, you got to know that stuff. That's the geometry. The math on that one, those two, were really, really easy if you know the geometry. Oops, not what I wanted. What happened there? I don't want that. There we go. All right, let's keep pushing the wrong button. All right, let's do this one. Find the values of x and y in order to make it a parallelogram. So in order to make it a parallelogram, then this side and this side would have to be equal to each other. So let's set them equal to each other. That's all you do. It's really simple. A lot of people just left this blank, and it's such a basic algebra problem. You just have to know that they're equal to each other. So 7x minus 24 equals 3x. Do the math, and you get x is 6. Okay? Then you do the same thing with these, right? This one and this one are equal to each other. So you go 2y plus, actually, let's do like this. 7y equals 2y plus 5. Do the algebra. I'm not going to do the algebra for you. You need to be able to do the algebra. Then you solve for y, and y is 1. So those are your answers. X is 6, y is 1. But you had to do some math with it. There's just no way you could just look at that and then write down the answer. Unless, well, I'm not even going to get into that. Okay. What about this right here? How do I know that this is a parallelogram? Let's see. 3y, 2y. Oh, I'm looking at the wrong problem. What am I doing? Let me see. Did I have a 1 point? What am I doing? I'm looking at my answer key. Why did I do that? 1.5x. Why did I do that? 3y plus 1. Yeah, it seems like... Are these the numbers I gave you on your test? Who's got the test in front of you? I just gave it back to a whole bunch of you. You should have it in front of you. Are these the numbers I gave you? They are? Yeah, that's what I'm thinking. I don't think they are they? So what was this 3y or 3y plus 1? So this one was? Yeah, somebody give me your test so I can see it. Yeah, I thought that maybe this thing that I put up on the screen, I gave it to you a little differently. Oh, yeah, that's really different, isn't it? Everything else was the same, wasn't it? Yeah, why did I change that one? I don't know. Oh, you know why? Because I told you I wasn't going to put any substitution on there, right? And so I must have made up another test and printed that out, but the one that I put up on the screen was the original test. Because I was like, I'm almost positive I did not give them one. So on this one, you'd have to do substitution, all right? I didn't put it on the test. Aren't you happy about that? So what I did do was this. I was really confused there for a sec. So let me shape that a little differently. Here's what I want this thing. And I made it go to the left, so let's go negative 20. There we go. Okay. Sorry about that. I'll just do it all in red. All right, here we go. Here's what's on your test. So this was 8, and there's the 1.5. I was looking at my answer key. I'm like, where did 1.5 come from? I don't see 1.5 on there. Yeah, I made this really nice and easy for you. At least I thought I did. Let's see what we got. Yeah, let's just set them equal to each other. Remember the diagonals of a parallelogram bisect each other? So this and this are equal, and this one right here is equal to this one right here. So it's just basic algebra again. So 3y plus 1 equals y plus 7. You can do the math, and it was still 4 and 3 though, wasn't it? That's weird why I still got the same answers. Is it? So that's 2y. Let's just do it like this. Minus 1, that's a 6, so y is 3. Yep, it still works out the same as this problem right here. So this problem and this one are completely different, but you still get the same exact answers. Maybe I did that on purpose. I don't know. And then what do? You do the 1.5x plus 2 equals 8. So you subtract 2, so 1.5x equals 6, and you divide by 1.5. You can do that on a calculator, and you get x equals 4. So x equals 4, y equals 3. There you go. All right. Sorry about that confusion there. Oh, to 14. I must have made a second page to this. Did I? It's so weird. Anyway, let's just do it like this. Let's just I don't need that actual test there. I'll just write it down. Oops. There we go. So I will just write them down now. There we go. Let's make this white. There we go. And now I got my test in front of me. All right, let's do this one. This is a trapezoid, so it's going to take a little more time because I got to write. Yeah, we're definitely not getting to chapter 5 today, but it's still going to be on the test. All right, I've said it a few times today. Chapter 5 is still going to be on the final, so you're going to have to go through, watch the chapter 5 videos. You don't have to watch every single one. Maybe I did a review. I don't know if I did a review for a quiz and recorded it. I don't know. You're going to have to look and see. So this is A, B, C, and D. And this is 5x plus 2. This is 3y. This is 3y minus 6. And this is 3x plus 2. All right. You got two different variables. You got x and y. So what are we doing? Are we setting these equal to each other? Is this angle A and angle B equal to each other? Everybody look at it. There's no way, because this is obtuse, this is acute. There's no way they're equal to each other. Neil, you love this answer. I ask every time and you always win the answer. So what are they to each other? They're supplementary to each other. So that means we add them up. All right, there I added up those and I set them equal to 180. And that's number what, 15? And they ask for angle B and angle D. So you got to solve for y first. So when you solve for y, you get 31. When you get y by itself, but you want to find angle B, so what do? Put that 31 in for the y here. 3 times 31 minus 8 or minus 6, and angle B would be 87 degrees. All right, so that's angle B. Then you had to do x, do the same exact thing. You add those up. So 5x plus 2 plus 3x plus 2. Set that equal to 180. Then you do your math, and you get x equals 22. After you do all that, you can do that on your own. And then it says find angle D, which is this one right here. Okay. And yeah, you plug it in, you work it out. Angle D is 112. There you go. All right. A couple more. That was 15 and 16. So 17, 18, 19, 20. 4 more. And I got 4 minutes. 1 minute per. Do you think I can do it? Kind of doubt it. 17. Here's a trapezoid. All right, this one a lot of people missed. So let's definitely do this one. And then all right, and this is a mid segment. Here's what they tell you. It says it's a trapezoid, and it says MN, which is that middle one, is 43. RS is 54, which is the bottom one, 54. And you want to find the top one. We'll just call that A. All right, here we go. Everybody watching? Let's get this right on the test. They could be different numbers. They probably will be different numbers. Almost guaranteed. Yes. This is 17. This is 17 on the test. Okay? So what do? The middle one is equal to the top and the bottom one added up divided by 2. Did you hear me? So the mid segment, so there's 2 ways to do this. Let me show you the easiest way. How far is it from 43 to 54? Be 11, correct? So how far is it? If this one's in the middle, then how far is it to there? It's 11. Agreed? So what do? Do I add 11? Do I subtract 11? Do I multiply by 11? What do? Subtract 11 from it. What does that give you? 32. Is that the answer? Yep. That's the easiest way to do it. There's another way to do it algebraically, but that's super easy way to do it. I don't think I showed you that when I first went over that problem. I think I might have mentioned it. Yeah, now that I think about it. I don't know. I taught it 3 times this year, so I can't remember what class I said what in. All right. 18 and 19 is a kite. 18 is a kite. Let's do that super quick here. I'm just going to draw this as quickly as I can. I mean, not be super accurate, but that's okay. So this is 124. This is 103. And they ask you to find this angle and find this angle right here. Okay, this angle right here, this is angle A. That's a super easy angle. Okay, this angle right here is super easy to find. What is it? Without doing any math, what's that angle right there? Quick. It's 103. 103. Because these opposite angles right here are equal. Are these opposite angles equal to each other? No, they're not. But you do have 4 angles. So what do all 4 angles add up to be? What if you have a 4-sided figure, quadrilateral, what do all 4 sides add up to be? 360. So you add those up, take it away from 360, and you get 30 degrees. Right there. Okay? That's how you do it. Super easy. One more. Let me draw it. The bell's going to ring any second, but just hang on just a second. Let me just finish this one problem. All right? Because you're going to see something like this on the test, so you might as well sit around for it, right? And then you got diagonals right here, and you got a diagonal right there. Okay, just hang on. The bell's going to ring, but hang on. It says that these two, it's a isosceles trapezoid, so those two are equal. It says find QS. So here's QS. You want to find that. QV. I said hang out. I said hang on. I said hang on. Well, just hang on. Just play along. You can't just play along? Okay. All right, so here we go. QV is 24. So QV, that one right there, is 24. TV is 20. All right? Watch how easy this is. All right? And you want to find what? QS? This whole thing. So what's this little bit right here? What's VS equal to? Because these two are exactly the same. So this is 20, right? This is 24. The question is, from Q to S, what is it? What do you do with those two numbers? Just add them up. That's it. You had to put the 20 there, add them up, you get 44, and that is your test. Now again, for about the 5th time today, I did not go over chapter 5. That's still going to be on the midterm, or the, whatever you call it, the final. All right, so make sure you look over chapter 5, because we didn't talk about chapter 5. Make sure you look it over, and you'll be good. All right, see you on Tuesday at 8 o'clock. Okay? Tuesday at 8 o'clock. That's your test.